In this video, we'll be looking at the power of a power property for our exponents. And just to give one example, let's say we had x squared y cubed all raised to the fourth power. So this is what the power of a power property does. So we're taking the power of other powers. That's why it's named that. So how do we handle it? Well, I call this the outside to inside rule. So this exponent is outside, these are inside. So when it's outside to inside, we multiply the exponents. So I have a 4 times a 2 there for the x exponent, so that would be x to the 8th. And then I have outside to inside here a 3 times 4, so that's 12, so I have a y to the 12th there. So that's how the rule works. Outside to inside, we will multiply the exponents. And you need to remember that the exponent has to be brought in for every factor inside the parentheses. You can't just take it, for example, for the y cubed. It also has to be applied to this x squared factor as well. Alright, let's look at some examples starting now. Alright, here's our first example. So we have 2k all squared. So I'll rewrite it as 2 to the first power, k to the first power all squared, so that we can see what's happening. So we have to bring in the exponent of 2 to both the 2 and the k. So it becomes 2 squared, because outside to inside we multiply. So we multiply that 1 times that 2. That gives us this 2 right here, that square. And then k squared as well. So 2 squared k squared, and then finally that will equal 4k squared. We want to go ahead and make 2 squared, turn that into 4 here for our final answer. So let's look at another example. In this example, we have a 0 exponent inside, 3 exponent outside. Outside to inside we multiply, so we multiply that 3 times 0, and we still get 0, so x to the 0 equals 1. Remember from previous videos, anything to the 0 power except 0 is equal to 1, so x to the 0 would be 1. So that's it for that one. Let's look at another one. Next example, we have 2m to the fourth all raised to the third power. So remember, I have to bring the exponent in. We'll put an implied exponent of 1 right there with that 2. It does have an exponent. It's just 1, and it's implied, so we don't have to write it generally. But to remind us that we do need to bring this 3 in and multiply it by that 1 exponent, we'll list it there. So it would be 2 cubed, m to the outside inside multiply, 4 times 3, 12, so m to the 12th. 2 cubed is 8, 2 times 2 times 2 is 8, so 8m to the 12th would be the final answer on that one. Let's look at some others. Alright, in this next example we have 2m to the 0 power n cubed all raised to the fourth power. We can handle this m to the 0 power in more than one way. One thing we can do is just go ahead and cross it out because it is 1, so 2 times 1 inside here is just the 2, so we can go ahead and cross it out. Or we could bring the exponent inside there, and 0, we would be multiplying the exponent. 0 times 4 is still 0, so you still get m to the 0 either way, and you have to end up canceling it later. So we'll just cancel it now. So we'll bring the 4 in as an exponent to that 2. Remember, there is an implied 1 as an exponent for that 2. We multiply outside to inside, so 1 times 4 is 4, so 2 to the 4th power. And then here, outside to inside, we multiply, we always do. N cubed raised to the 4th power would be n to the 12th. 3 times 4 is 12. That's where this exponent of 12 comes from. And then if you work it out, 2 to the 4th is 16. So final answer, 16 n to the 12th power. All right, let's look at another one. Alright, in this example we'll end with some negative exponents, so we'll be applying our negative exponent rule at the end. I'm going to go ahead and write an exponent of 1 right there for that 2 because it's implied, but it's nice to write it so we can see what's happening. So we need to multiply negative 4 times that 1 and negative 4 times that 4 right there to get our exponent. So it would be 2 to the negative 4 power and x to the negative 16 power. Remember, outside to inside we multiply, so 1 times negative 4 gives us that negative 4. 4 times negative 4 gives us that negative 16. So what we can do now, both of these, the 2 and the x, 2 is the base here, negative 4 is the exponent, x is the base here, negative 16 is the exponent. So both of these bases, the base of 2 and the base of x, both have negative exponents, so we're going to take them down to the denominator. We will have to leave a 1 in the numerator for a placeholder, and then we make the exponents of both of these positive when we write them down here in the denominator. So 2 to the 4th x to the positive 16. And then 2 to the 4th is 16, so we'll simplify that a little more and leave it that way as 1 over 16x to the 16th. So that would be our final answer on that one. Let's look at some more. All right, in this example, we are raising this quantity right here to the 3rd power. We have a 0 exponent right here, so we can go ahead and just take that factor right there into the 0 power and mark it out because it's just 1. So, and work from there. So remember, we have an implied 1 on that 4. So we multiply outside to inside. So that 1 times that 3 gives us an exponent of 3 now for this 4 here. Base is 4, exponent's 3 there. And then m to the 4th cubed would be multiplying this exponent of 4 times this exponent of 3, so m to the 12th there. 4 times 3 is 12. And then here, outside to inside, as always, we multiply, so p to the 12th power from that. And then 4 cubed, if you work that out, is equal to 64. So 64 m to the 12th, p to the 12th will be the final answer. And just so, a little review here, 4 cubed means this, 4 times 4 times 4, so 4 times 4 is 16, times 4 is 64, so that's where that comes from, just a little reminder there on that. Alright, let's look at another example. Alright, in this example, we're raising this quantity to the 4th power. We're using our outside to inside rule, the power of a power rule, and we multiply the exponents outside to inside. So there's an implied 1 with that too, so it gets multiplied by that 4, and that gives us an exponent of 4, so 2 to the 4th. Here, this p cubed, right here, we raise its exponent to the 4th power, and we multiply those two. 3 times 4 is 12, so p to the 12th. And r, we have a negative 2 times 4, so that's negative 8. So we have 2 to the 4th, p to the 12th, r to the negative 8. 2 to the 4th power is 16. The p to the 12th is going to stay on top with it, but we have this negative exponent here, so we take it down to the bottom and make its exponent positive. That's the negative exponent rule. So final answer there will be this, 16p to the 12th all over r to the 8th. Let's do one more. Alright, last one. We'll end with a super easy one. So if you understand the 0 exponent rule, you know that anything to the 0 power is 1 as long as the base is not 0, right? So anything other than 0 raised to the 0 power is 1. So this whole thing right here is raised to the 0 power, so it is simply equal to 1, and that's it. Alright, that's it for this video on power of a power.